So what we've got is a vertical soilless growing system. It works by putting plants into the front of the tube with the roots out in the back box. So the roots are completely out in the open, not in any soil. We then spray the roots with a nutrient mix for 10 seconds every 20 minutes. So that gives the plant all the water and nutrient it wants, but it also allows the plant to absorb a lot of oxygen at its root. That means that it's forming its oils and sugars much more efficiently, so the plant grows faster, it gets much bigger yields, and the nutrient that isn't taken up gets recycled right through the system, will come out the other end and will be recycled back through the system and replenished. So that saves 90% of the water that is normally just poured on the ground in traditional farming. When it comes to harvest time, you harvest your plants out and completely replace them. So these then come up to their flat packed. You replant the plants in there, usually with a pick and place automatic machine, close them over, and they go straight back into the growing lines again. So it's a very fast, efficient system that allows for rapid turnaround of all the crops. So this is one of our walls in action. It's a cooler wall, so we're growing a lot of native species in here, as well as actually some Mediterranean species, and they're all growing on the same nutrient mix. So all of these are growing on a very general nutrient mix, although we can specialise for particular crops. We've got a strawberry here, which is just starting to fruit, and again we can take that out, put it in a pure strawberry mix, and it will do an awful lot better. It's a great, the strawberry business model is a great business model because you're growing so many plants in a single footprint. As we move up here, we've got another section of our growing area. This one is quite dedicated to chilies. We've got some of the hottest chilies in the world here. We've also got some experimental chilies which seem to be slightly hotter, so we're looking for a bit of a gold medal on these ones. We've also got some really interesting herbs and we've actually got a groundnut and a maize crop growing in this as well. So those are pretty much unheard of as growing as hydroponic or aeroponic crops. Again, we're looking to take that sort of possibilities into Africa and be able to feed them their main starch crops, which are not affected by insects and disease. So those are where we're heading with this lot. We've got a whole section here which is, again, we've got some highly scented herbs, we've got mints, we've got asparagus, which is pretty much unheard of, again growing in a hydroponic system. We've got a tree at the end there which is a Japanese hardwood tree, which grows incredibly fast. We're now starting a whole new project in that with renewable fuels. So again, all in the same sort of mixture. This has a very specific mixture. We're growing chilies throughout because they're our barometer about where the nutrients are going. This last bay, we've got some stress testing going on, and the more you stress a plant, the more it has different reactions. So we're not really about precision growing, which a lot of people say we are. We're actually about precision stress. So you can make and steer these plants to do all sorts of other things. So this is where we're limiting its water supply, so it will produce an awful lot of fruit in a very, very small area. Once you actually get that right, you're producing full-size fruits at a much higher density than you normally would. The melon at the end there is a Pepino melon, really has absolutely no business growing here. We've been stressing the life out of it, and it's still producing a lot of fruit continuously, and they're really very nice too. So that's what we're up to here. We've got a lot of these LED lights. There are a lot of high red light. High red tells the plant it's being overshadowed, or it tells the plant that it's coming up for autumn. So it will trigger all sorts of responses, either fruiting in a fruiting plant or bigger leaves in a more leafy green. So this is the nutrient system. It's topped up again from the water barrel. We mostly use rainwater in these, but it keeps a level amount of water in here so that the nutrient level is always the same ratio. This is actually just the brain of the operation, so it's a small Arduino. It runs a whole relay board here, but it's also getting fed back with quite a lot of information from the sensors. We don't, again, take a lot of information. We take information at very salient points. It's taken us a long time to work out where to take that information from to get a meaningful average that will actually work for the nutrient mix. So we use mostly an LED system for lighting. It's much more efficient, it's much cooler, and you can get the lights a lot closer because they don't radiate so much heat out the front. We use all sorts of lights. The thing that we try to do with lights is take the plants back a million years to the point where they were evolving at the peak, and they were pretty much the only thing on the planet. So that we like to have a high CO2, we like to have a slightly red light as if it's being filtered through a dusty atmosphere, and we find that to be the most effective way to light these. We can go to that red and blue peaks, but what you get is you're eliminating the ambers and greens, which are essential for stalk growth, so you end up with floppy plants. Very often we stick to some pretty much white full spectrum light that we alter the top and bottom range of the phosphorus caps.